Hi, I'm David Coley from the Plastic Piling Company. Thank you for spending the time to watch this video today on plastic sheet piling and methods of installation. We work with a range of different clients who tend to focus upon broadening their range of activities to keep abreast of new developments. Most of them have a need in the marketplace to find something which is a bit more long-term and a bit more maintenance-free. And that's where plastic piling comes into it. The fact that you're watching this video may mean that you have a certain issue to do with a retaining structure, a maintenance issue. You may have curiosities in terms of what plastic piling is available, how it's installed, how you can use it. You may have questions upon, is there an application that I've got that it could be used for? Well, throughout this presentation, I hope to answer your questions. If not, please contact me directly. You can contact me by telephone, email, or through our social media streams. Now, our social media streams are split into 3 product areas. We have the Hammerman equipment, which will requires reference to our pile driving equipment, our Mandrels, and our handheld equipment. The basis of this presentation, which is plastic sheet piling, as used in a variety of different applications for water control and soil retention. Also, Jet Filter Europe. Jet filters. These are drainage filters used to allow water through a structure but to prevent erosion. Now, over the last few years, I spent an awful lot of time presenting about plastic piling and the history of plastic piling. Now, the basis of that, to me, has a strong parallel to the story of Pinocchio. The very early products were made to look like sheet piles, but they didn't actually behave very much like a sheet pile. And like the story of Pinocchio, they went through a range of different trials, and now I believe that we do have plastic piling, which is a real sheet pile. Now, what does PVC and plastic bring to sheet piling? Well, in terms of the material, this is extremely long-lasting and durable. We have a situation where it's resistant to biological agents. It's resistant to acids and alkalis. Very importantly, though, it's very environmental in the fact that it's very recyclable, and therefore you will probably find that you have a product now which, instead of going to landfill, is now having a very useful application in the 2nd or 3rd life. You can recycle PVC successfully 6 times. One of the key areas and applications that we come into is those where they're looking for a low-weight product to reduce manual handling hazards. Now, so you bring this through in terms of PVC as piling, we know now that's going to last a very long time. It's going to outlast steel, it's going to outlast timber structures. It's very economic. It's one of the best plastics to work with that give you a good balance between properties and also economy. It's going to give you a very safe working environment. There's no hot work. You can easily cut the product on site by using basic reciprocal saws. Again, manual handling, it's very light, and so you can carry around site without fear of injury. For our motorway customers, the fact that it's fire resistant makes the product universal throughout the railway industry, waterways, and also the highways. Because the product's also light, we have very efficient transport for our customers. So we can take smaller vehicles to your location, causing less disturbance. Now, often we're asked about how does plastic piling compare to one thing or another. The important, perhaps the most important thing to address is that there's more than one plastic pile. We ourselves offer quite a comprehensive range. Basic trench piles for shoring applications, Z piles, U piles, and also our advanced range. Now, there'll be a variation of cost amongst this range, but you'll also find there's a variation in performance too. Some will outdrive others, some are stronger than others, some are more versatile. So we'll cover some of those points in a moment. Going through the range, the lightest section that we do is the trench pile. I brought this into the range primarily for utility contractors. They had a need for a very narrow section, a section that could have a centre pan to fit in a wedge. So when they do their trench excavations on roadways, reinstatement costs are minimised because the actual trench sheet is taking up less space than a more thicker plastic pile. They can be used for erosion control projects, but they're very light gauge products. We're quite a niche product. Moving on, Z piles are perhaps the earliest plastic piles that came out. There's quite a range from sort of 3.5mm thick, very light budget sections. For instance, sections such as the EcoZ. This was the first plastic pile ever to hit the UK. And for about 10-15 years, it's probably the only plastic pile we saw. Now for its own application, the section, it's a well-made section. But it's very light duty. And so for many applications, we're looking for something a little bit more substantial. And so we offer Ultra Z products, which incorporate the 7mm and the 11mm. In the photograph set that you're seeing at the moment, the Z pile was selected primarily because of its extra thickness. The application was a seawall defence, and they were concerned that the actual erosion issue that could occur with sand rubbing against the plastic piles may be an issue that could affect design life. And so they went for a slightly thicker section. We can get them in length of up to 14 metres, so they're quite substantial. We also have a situation where the heavier end are quite expensive because there's a lot more plastic. But they do offer good drivability, and they do offer optimum strength. The Ultra Z is probably one of the strongest sections that we do. U-piles. It was inevitable that we would have U-piles in plastic, mainly because the development of steel piling was Z piles first, and then they realised there was an issue of drivability in the fact that contractors tend to love U-piles because they're a far better balanced section. And therefore early installation issues with Z piles, it was natural for manufacturers to say, okay, let's mirror what happened in steel. In reality, they tend to be quite new sections to the market, but we do have quite a comprehensive range, from a 333 width right way up to 600mm. We also have the advantage that we have a budget range, which gives you the economy, which will be what we call a mono extrusion. This is where it's the same throughout, a single layer is produced. We also do a premium range. Now the premium range is co-extrusion, where you can actually see a different colour on the outside. We do actually have now 5 colour options, and we have this available in 2 sizes, the 460mm and the 600mm. Again, we have a situation where we can get them in quite substantial lengths, up to 14 metres. The advanced piles. This incorporates our section of the biggest selling products that we do. These were the first plastic sheet piles that stopped copying steel designs. They introduced new designs that could be made easily in plastic, but virtually impossible to make in steel. You'll see a lot of tubular designs, and as a result, we get greater rigidity, we get improved aesthetics, better drivability, and as you'll see soon, they can be used on their own or as a hybrid. And I'll cover exactly what I mean by a hybrid in a moment. Plastic piling hybrids. This is where you will combine a plastic sheet pile with another material, and it can be softwood, steel tubes, or concrete. In this representation, we see how the hybrid system fits together. By using a shorter length of plastic sheet piling with a longer timber post, we get not only the lowest carbon footprint, because we're combining sustainable with recycled, we also get far better economy, because you're using less of a better quality product. In this example, it's the multi-lock sheet pile with softwood timber post driven every other tube. In this design, you can drive 2 timbers per pile or 1 timber per pile. Obviously, 2 timbers is stronger. I have certain customers that will look to have timber in 1 pile, and then for a factor of safety or a confidence factor in future years, timber in the other pile can be put in later on, or steel if they're looking for more strength. In this representation now coming up, you will see a cross-section of the system. In this cross-section you will see we have the multi-lock sheet piling coming down to a relatively shallow depth, around about 1/2 metre into the ground, and it's tied back to an anchor at the back here. The timber post is much longer, and what the representation is showing is that yes, in the short term, the timber at the top can rot, but in the long term, the timber below will last indefinitely. One of these interesting side effects, or the related areas that this hybrid designs come into, is in breach repair. Historically, this sort of application would involve a lot of people bringing out sandbags. In this case, our customers sought something that was a little bit faster to install. And the advantage of carrying quite light plastic piling and quite light timber to site meant they actually could fill the breach very quickly. And then that gives them more time to fill the size of the seawall. We're having a number of farmers now looking at these applications for rapid installation, because sandbagging is often what you could call traditional for emergency works, but it's incredibly labour intensive and there's a lot of material to move. In this slide, we have a picture of Prologue. Now, Prologue is a more heavy-duty version. It has a flat front and uses a larger diameter timber, 150 mm, so it's more for substantial structures. In this example here, this is where hard engineering meets soft engineering. One of the biggest critiques of sheet piling has been that it looks very artificial compared to a natural river structure. However, a lot of the natural systems, such as geotextiles, don't tend to have the longevity of sheet piling. So we offer a compromise solution here, where the hard engineered structure is no longer visible, it's driven below the water level. But the hybrid posts stick out, and onto those posts you can attach core rolls or Nick-Span type products to give you a more natural appearance. It's one way of working with the best of both worlds. This is an example of a product called T.H.E. T.H.E. can be installed on its own and infilled with gravel, but it also can be used very similar to formwork, where you can put concrete inside it. So again, we're getting the best of both worlds. We're making a hybrid through combining concrete, steel, and plastic. Having plastic on the outside where it's going to protect the concrete and the steel from the corrosive environment. Again, here you'll see that the actual rebar is exposed, and what they'll do then is they'll make that into the capping. Now, multi-lock. This is one of our advanced piles, and it is our biggest selling product. It consists of a section which is 500 mm wide and has 2 hexagonal tubes. Because this section is so rigid, it is fast becoming our main contender for cut-off walls. Because this section can withstand a far heavier, more powerful hammer, for instance the EMV 300, than its steel counterpart, which would be the M7, the L8. And we're routinely now driving this in lengths from 4 to 6 metres, and in Holland they've managed 11 metres. This is an example here which will show you scour protection for network rail. Our application at the bottom is used on the M6 and above on the M1. Multi-lock is the only plastic pile that's been used on the M1 and the M6. Multi-lock also tends to be used an awful lot for the creation of structures. And where water tightness is important, we now have the added advantage that multi-lock is available as a second version which has a seal built into the clutch. And this gives us the main benefits of the installation speed of multi-lock, the appearance in some cases, but also gives us the added advantage now that it's the only plastic pile with an inbuilt seal, a seal that's created at the same time in production, so it adds no extra cost. Both the standard multi-lock and the self-seal are available. As mentioned earlier, Prologue is a more heavy-duty version of multi-lock, and it consists of a product that has a flat front with a tubular back. Ironically, in many applications, people looking to get close to a structure will find that they're turning it around to give them a flat surface to work against, as in this case. This again was scour protection, where you can see at the bottom of the seawall, water erosion is getting under the foundations. By putting plastic piling, we can do routine repairs, And by having the front actually faced backwards, we can now actually get a situation where we can work flush with the structure. Prologue tends to be one of our favourite products for clients that are looking for an aesthetic finish. For instance, ha-ha constructions, where you want the illusion of a flat edge. Having a flat-fronted product gives you that facility. So therefore it's quite important and quite interesting to use this for golf courses and other landscaping applications. Trueline. Trueline is our most heavy-duty product. As mentioned previously, it can be used on its own, but you can infill with gravel, or you can use it with concrete. It's a modular system. As such, the Trueline main element is this U shape here. But also available are a number of corners and cross ties to make the section stronger and to navigate through corners. If you want a square corner issue, then quite simply we can put a male fitting onto the U-section pile. The above scheme is based on Aberystwyth. In this scheme, the contractor was looking to produce a dam and a sluice structure for storage of water in a hydroelectric scheme. In the hydroelectric scheme, the problem was the actual location was very remote, as they couldn't get steel piling. Also, they found that under 3 foot of peat they had rock. And so in this application, they dug down through the peat, levelled the rock, and put Trueline on top and infilled with concrete. And therefore you actually had plastic piling growing out of the rock. So it shows that working with different materials gives us a lot more versatility than we ever had in sheet piling. Now, installation. One of the biggest questions we get asked about for plastic sheet piling is installation. And this is probably to do mainly with the history. The very early products, such as the basic Z profiles, and even the Ultra Z sections, were very flexible. And as a result, plastic piling gained a reputation that it was too flexible to install. However, as you've seen through the presentation so far, there's quite a range now of plastic sheet piling, and equally now we've seen a range of new methods that have come forward. First of all, we have handheld hammers and mauls. These tend to be what I describe as a last resort measure. We always advocate, whether you're driving steel, timber or plastic, to use the largest hammer that you're capable of using, simply because most of these jobs do not know what kind of soil they're going into. And when driving any kind of pile into the ground, it is very important to ensure that you have sufficient force to overcome the ground resistance. And obviously handheld hammers and mauls are very, very small, hence portable and get into sort of tight sites, but they don't have the most power. In soft driving conditions though, they're perfect. In this video, they're driving at the sides of a lake, and so we're talking puddle clay, so it's very, very soft. They're also driving a relatively narrow sheet pile. And what we tend to find with handheld equipment, if that's the remit for the job, it has to be handheld. You're better off looking at the narrower sections, so the 300mm wide sections. And to get the rigidity, the thicker sections. So for handheld equipment, we would say the Ultra Z is probably one of the main contenders to consider. Air hammers have a long history in the use of the canals, and they've been used for the last, must be close to 100 years. Very early versions were steam powered. The main reason why air hammers are so prolific, or prolific on the waterways, is because they're available in very small sizes. And to date, there are very few or hardly any small hydraulic-based impact hammers. Air hammers have been used extensively to dry plastic piling. The main limitation tends to be the width of the anvil block that's resting on the actual sheet pile. If the anvil block is too narrow for the plastic pile, you can start getting top damage. In fact, one of the main areas where we moved away from air hammers was because of the rapid blow that we have, you do run the risk of generating an awful lot of heat. And whilst PVC actually is remarkably resistant to damage, if you get it warm, it will begin to soften. This video shows the installation of plastic piling at Drayton Manor. They basically they pushed them in most of the way, and now we're just doing a finish drive. So rather than use the air hammer throughout the entire process, to make it a more quieter process, and because the ground was quite soft, they pushed the sheets in before finally just towing them in with the air hammer to get resistance. In this product here, you have the Euro pile. Now, not strictly a pile driver, but one of the main areas that we have seen great improvements in driving plastic piling is the use of compactor plates. Compactor plates are excavator-mounted attachments. They're rigidly mounted, and they're typically designed to consolidate and compact the ground. However, they can be very effective pile drivers. They act somewhere between an impact hammer and a vibrator because they're not connected to the pile, but they have a very high frequency which will vibrate or high frequency ram the pile into the ground. In this example, you've got Prologue being driven by a compactor, and you can see it's relatively rapid installation. Excavator-mounted vibrators. These perhaps have been the biggest innovation in sheet piling for the past 15, 20 years. The use of a piling vibrator but powered by an excavator, also benefiting from additional crowd forcing from that excavator. The main reason why these become so successful for plastic piling is that, in common with the air hammer we saw earlier on, they're now available in a variety of smaller sizes. This shows you one of the ESF range of vibrators on a long-reach machine. Such a format is quite common, particularly if one's working with Mandrels, and I'll cover Mandrels later on. This shows an example of an EMV70 driving multi-lock sheet piling. I like this scheme primarily because 5 years previously the scheme had been done in steel, but because of the acidity in the ground, the steel didn't last very long, and so they're doing it properly now, they're putting plastic in. This particular vibrator is clamped directly onto the plastic pile. It weighs half a ton, and it just shows you the kind of strength the plastic piles now have. This has a 7-ton vibratory force. The beauty of excavator mounting, again, as you will see, is that they can push through the vibrator to facilitate the installation process. And as you can see, installation is relatively steady. One issue that people tend to find with this type of vibratory hammer is the need to actually keep on adjusting. An excavator's arm doesn't naturally push down straight, and so what you can see periodically is they'll stop and they'll readjust the vibrator to make sure that it stays in line. And this is one of the reasons why driving with an excavator does limit the length of plastic pile that you can work with, because obviously the longer the pile, the more difficult it is to actually maintain that line. Crane suspended vibrators. Recently, we've seen a big increase in the use of vibratory hammers used in sheet piling through excavator mounting. It's only within the past couple of years that we've now brought into the country a range of small vibratory hammers that can work off very small packs. And so you now have the added advantage of using traditional suspended vibrators to drive plastic piling in quite tight access sites. In this example, we are actually showing steel, but the concept shows basically a crane-mounted barge, vibro driving the trench sheeting, and likewise we'll do a similar thing with plastic piling. This gives you an example of the next size up, which is the ESF1, driving a very flexible plastic pile. Historically, you would never have been able to drive that type of pile with a suspended vibrator, because now these smaller sizes are coming forward. The pile has the ability to support the weight and withstand the forces. And so now even the most basic EcoZ type product can now be vibro driven. Now the vast majority of applications will still be excavator mounted, but there is one final category of vibratory hammer that has been used very successfully to drive plastic sheet piling, and that's leader rigs. Leader rigs are purposely built pile drivers, where you actually have a mast built onto a carriage, and onto that mast you actually have a vertical stack vibrator. It's quite clear the advantage that you have is verticality. You haven't got that excavator pushing over. You've got complete verticality. And as a result, you have the advantage of driving much longer lengths. In this example here, we're driving 11-meter multi-lock. One advantage to leader rigs is that you can change the attachment, and it's quite common to pre-auger, to loosen the ground ahead of pile driving. Again, in this particular video, there's a vertical stack vibrator coming down the mast, putting an internal mandrel inside the multi-lock plastic pile and making it more rigid. This is one of the first applications that use the multi-lock self-seal, and it's a cut-off wall application. And as you can see, that verticality gives you a lot more control over the driving process. And we do envisage seeing a lot more growth in the use of leader rigs over the next few years. One of the disadvantages to using a leader rig is that you don't have the reach that an excavator has. You're typically working very close to the piled location, and therefore access can be an issue. So generally speaking, when we're asked about, well, what length can you drive, there are certain issues to consider. First of all, manufacturing. Certain products can be produced at different lengths. The maximum length for U&Z piles tends to be 14 meters. Multi-lock, Prologue, those sort of products tend to be looking around about 9 meters production. The length of the pile can affect transportation. And obviously it's important to see if we can actually gain access to a certain site. Length also influences rigidity of the pile. The longer the pile, the more flexible it will become. And that can also determine how far you can drive it. In the UK, the typical length that we work with is 4 to 6 meters. Now, other factors that can influence, which we've touched on before, is the issue of excavator mounted versus crane suspended versus leader rig. In those issues, we have a case where the excavator doesn't push down straight, and so this can limit the length of plastic pile that we can work with. You also have a situation where soil conditions will influence the length that can be driven. From what you've seen so far, we are very much vibratory based. Now, vibratory hammers are fantastic pieces of kit, but they do have limitations in hard driving conditions, and therefore that will limit us to those sort of grounds that we can drive into. As a rough gauge, an SBT level of 30 and below will be okay for a vibratory hammer. One thing that we've seen as well is a restriction in the type of equipment that's available, but fortunately over the last 5 to 10 years there's been a great increase in the number of small hammers available in the UK for driving trench sheeting, plaster piling and timbers. One of the main areas where we've seen a great improvement is our development of mandrels. Now, a mandrel simply is a steel fabrication that rigidizes the pile during installation. And you start off with the basic side sleeve, which consists of a metal angle line that slides over the interlock, and that gives a metal spine to one side. Moving on to it, we have side mandrels. Now, side mandrels are a bit more sophisticated. They will be a steel replica of the plastic pile. And finally, with the advent of the advanced range of equipment, we now have a range of internal mandrels. Now, individually going through, the side sleeve is a basic fabrication, typically limited to relatively short sheet. We found it very useful in driving light and budget sections, generally limited to around about 2 or 3 meters, simply because the handling of it can be an issue and it's quite easily damaged. It must always be shorter than the plastic pile. And the reason for that is that if it's longer, you can get a soil plug, which can result in the pile being pulled out. But one of the advantages is it's quite universal, and it can be used on a whole variety of different sheet piles. What we're seeing in this video is a side mandrel. A side mandrel is what we produced to give you a bit more rigidity for driving more heavy duty and longer sections. It is a steel replica of the plastic pile, and it is driven always ahead of the sheet piling. The mandrel provides the sheet with a degree of support at the top and all the way down the side. At the same time, it minimises contact. Because of this, it is much safer than rear-based mandrels, and much more effective than rear-based mandrels. The American system, stab cats and path claws, rely on a substantial amount of steel behind the plastic pile. And as a result, you have as much contact between the mandrel and the pile as you do between the pile and the soil. And so upon extraction, you've got a 50-50 chance if the pile is pulled out. Indeed, the early stab cat information gave you a redrive methodology to work to. By side driving, we have absolute minimal contact between the plastic pile and the sheet. And what you'll see when the sheet's pulled out, sorry, that the mandrel is pulled out, is that the sheet stays in the ground. Side support is also very important to stop the sheet from buckling. If you look at a lot of the American videos, you'll notice there will be vice grips along the length of the plastic pile and the mandrel, about 5 foot from the bottom. And these are typically used there to stop the pile from bowing out. With our designs having side support the whole way along, you don't actually have that issue, you've got side support. Downside is there's a lot of steel there, and that's quite common with rear mandrels too. And as a result, the mandrel is quite heavy. Now, the heavier the mandrel, the bigger demand it puts on the piling vibrator, and so you tend to have a larger piling vibrator. As a result, everything starts growing in size. They're also relatively expensive to produce in comparison to side sleeves, and they are bespoke to a particular pile shape. Now, with the advent of multi-lock and the other advanced piles, we gained products that actually had an inside area, the tubes. And when we're doing cut-off wall applications, we can now use the insides temporarily using something called an internal mandrel. And this basically is a steel fabrication that fits inside 2 steel tubes and pokes out the bottom. The method is effective because it gives you the rigidity where you need it. It also eliminates and reduces toe friction by having a wedge lead on the end of the pile. It also stops plugging and the internal friction that you can sometimes get with the advanced range, because we have an internal area to contend with, and so we have internal friction as well as external friction. In this video, this was the first use of the internal mandrel by the Environment Agency in Bradley, and we're driving 5-meter multi-lock. What I like most about this video is the fact that the driving actually isn't particularly easy. What you'll see from the video, in this particular video setup, in this scene, and also in the next video, is that as we're driving through the ground, there's a lot of resistance that we're having to overcome. So the internal mandrel design, much lighter, and so we can get away with a much smaller piling vibrator, so again the size comes down. Or for a given size of piling vibrator, it is much more effective. Again, you can see steady progress here. And what you'll notice towards the bottom of the piles that have been driven so far is there's no top damage. Again, showing you the improvements in plastic piling, how far we've come. In this particular thing, you're looking at a 20-ton excavator with an EMV 300 vibrator, so a 30-ton vibratory force. So quite a substantial size vibrator. In fact, multi-lock was the first plastic pile that we've ever had that could use the EMV 300. As you can see now, we're going through different bands, and so it's quite hard driving. Now, generally speaking, people say to us, well, it's that hard driving. What about toe damage? Well, if you're getting a lot of toe damage, it's very likely that you'll see damage in terms of the mandrel, because the mandrel is pointing at the bottom of the sheet pile. And what you'll see when the sheet pile is extracted is that there's no damage to the toe of the mandrel. So even in hard driving, the method works well. What you'll see now as we're approaching the end of the drive is that when the mandrel's extracted, the sheet stays put. So unlike the whole rear mandrel methodology of redriving the sheet that's been pulled back out, we don't have that problem. You'll also know that the sheet has remained true. It hasn't bowed out in any direction, and that's because you've got the steel strengthener where it needs to be in the center of the sheet. Now we have these mandrels available for hire or for sale. Doing a little bit of vibration, and we'll pull the mandrel back out again. And again, no movement off the sheet at all. As we've discussed throughout this presentation so far, we have a strong bias towards vibration driving. Now the main reason for that is the lack of availability of modern impact hammers. Steel sheet piling has a whole myriad. Unfortunately, with plastic we don't. So we're extremely pleased to be involved in the testing of the new BSP hydraulic impact hammer. This is excavator mounted and has a leader mast to maintain verticality. In the video you will see that we're getting some quite powerful impacts through the actual plastic piling. 1,200 joules per blow. This is a substantial amount of energy and just shows you how durable the plastic piles become. Now what you'll see throughout this video is quite a steady installation rate, which is typical for impact hammers compared to vibrators. However, we'd often envisage this sort of hammer now being used to back drive a pile once it's reached refusal using a vibrator. The mechanism inside is the well-established BSP hydraulic design, which has been used for the last 20 years. The outside needs a little bit more development to help us interface better with plastic sheet piling, but development work is going on. And the trial was very successful, and we're very pleased that BSP realised how durable our plastic sheet piling is. So just to round things back up, we have quite a range now of plastic sheet piling to assist you in a whole range of different applications of water control, water exclusion, soil retention. It's important that you select the right pile for the job. Don't be driven by economy. Sometimes going for the cheapest plastic pile can cost more for installation. It's very important that you pick the right equipment for the job. Nowadays, if there's a problem installing plastic piling, it tends to be because the equipment on site isn't big enough to drive the pile into the ground. It hasn't got enough power to overcome the ground resistance. And as mentioned just then, we're very much vibratory based. Well, thank you for your time today and listening to the video. If I haven't answered your question, please email me, telephone me, or contact us through our social media streams. Thank you for your time.